Good morning, everybody, and welcome back to the Wide World of Economics. We are going to finish up with the law of supply today by talking about the elasticity of supply. Now, the beauty part of it is that all that time that we spent talking about elasticity of demand, many of the same principles apply. Aside from substituting out quantity supplied for quantity demanded, the mathematical formulas remain the same, and the principles of elasticity with regard to defining how it derives from the supply curves are also the same principles as in elasticity of demand. There are, however, with elasticity of demand, only 4 factors that affect elasticity. In supply, there are actually 8 factors that affect elasticity of supply. So we're going to talk about those. And without further ado, I'm going to go ahead and screen share here so that I can get the PowerPoint presentation up for you. And I apologize that took as long as it did. I'm going to stick myself over here in the lower left corner, and we're going to go ahead and we are going to review the slides under law of supply, elasticity. So when we talk about elasticity of supply, as I alluded to, it measures the relationship between the percentage changes in quantity supplied and the percentage changes in price. Again, very similar to how elasticity of demand worked. So we're going to look at how much the quantity of supplied items decreases as the price decreases, and how much the quantity supplied increases as the price increases. And if you remember back to our definitions, with elasticity of demand, we had what's called an inverse relationship. As price went up, quantity demanded would decline. With elasticity of supply, we have a direct relationship, where as the price of the item goes up, the incentive to supply more of the item also goes up, and therefore quantity supplied tends to increase. And of course, as price decreases, quantity supplied will also decrease as the incentive to provide those goods or services decreases. So as I said, the formula is the same. We simply swap out Q sub S, where we previously had Q sub D, and of course E sub S for where we used to have E sub D, because we're talking about supply S, not demand D. And I will post the link to the video that is behind this picture when I post this lesson. Now, elasticity of supply, again, goes back to the 3 definitions. We have elastic, we have inelastic, and we have unit elastic. And the definitions are fairly similar to those that we've looked at under elasticity of demand. Supply is said to be elastic when the quantity supplied changes by a higher percentage than the price. So when the coefficient of elasticity is greater than 1, it is said to be an elastic supply. Inelastic supply tends to exist when the quantity supplied changes by a lesser percentage than the price. So when our coefficient of elasticity is less than 1, the good or service is said to be inelastic. And of course, unit elastic, just like unit elastic demand, exists when the supply and the price change by the same percentage. And now, as I told you at the start of the video, there are 8 factors that affect elasticity of supply. We're going to look at each one in order, and I will try not to drag this out quite as long as I did with the elasticity of demand, but I do want to make sure that you have a clear understanding of them. So the first one is the number of producers that are actually out there. So when you look at a product that's manufactured by just one or two companies, those one or two companies uh, pretty much, I don't know, they don't really have a corner on the market, but they've got a real edge on the market because they're competing. Uh, if it's the sole source, they're not competing with anybody. If they're competing with only one or two other companies, it's not that difficult for each to figure out where their niche market is and exploit that market. Um, Conversely, if there are many companies out there that are producing a particular product, um, the uh, 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 the number of producers, like the number of substitutes, allows for a greater amount of competition. Now, the other factor when we talk about number of producers, the one that I have highlighted here in red, is the ease in entering the market. And there's several factors that control that ease with entering the market. If you have um, just a couple of large corporations that have a lock on production, large corporations will have a tendency to try to manipulate the law. They will try to get laws passed that include uh, regulations which are very time consuming and expensive to comply with. They will happily take a loss over a period of time if it means that they can undersell a new competitor and drive that competitor out of the market. Um, and the the richer, the wealthier a corporation is, the easier it is for that corporation to be able to take a loss of uh, profit in 3 months, 6 months, a year, whatever, um, and still have a significant bankroll in order to be able to drive new entries into the market out of business before returning their prices to normal. So the difficulty in entering a market, if it's very, very difficult for a new company to get into production, it is said that the supply of that particular product is inelastic. If it's relatively easy to enter the market, it is said that that supply is elastic. And that is because the easier it is to enter the market, the more likely you are to have multiple um, producers. Um, and when I teach this class in person, I actually have a fairly lengthy story about the automobile industry. For years, we had the big three automobile manufacturers, Ford, General Motors, and Chrysler. And all of the other automobile manufacturers like Buick and Dodge and Plymouth and Mercury and some of those other companies were bought up by one of the big three, thus taking the competition out of the market. Back in the 1950s, there was an automobile manufacturer called Tucker. And Tucker was essentially an independent manufacturer. He started out in his garage, and his goal was basically to make an affordable car that did not have planned obsolescence. It did not, you know, it was not built to break down every 3 years or every 5 years in order to generate new sales. It was actually built to last. And he was building this car using a very small production facility that he had eventually established, and putting it out on the market for a very inexpensive price. And so the big three auto manufacturers um, got together and put a lot of pressure on Tucker, and some of it legal and some of it not. Some of it was laws that they pushed for, zoning restrictions, and certain things like that to make it more difficult and more expensive for him to continue to operate his factory. They also resorted to some downright illegal activities. Um, little things like sabotage of equipment, maybe a fire or two, that sort of thing. And eventually they ended up driving Tucker out of the market into bankruptcy and preserved their market share of American-made automobiles. Now, the funny thing about it is there were only a very small number of Tuckers that were built. But the last time that I checked on it, about 3/4 of the Tuckers that were actually manufactured are still on the road 50 years later. And so it was actually a very good automobile. But in order to keep that supply inelastic, um, Tucker himself was driven out of the market. And up until we started deregulating the automobile industry, and we started seeing more foreign cars, not just cars that were getting imported into the United States, but foreign car companies that were actually putting up factories in the United States so that they could manufacture vehicles in the US and bypass some of the import restrictions. We really saw a market that was just dominated by the three major automobile manufacturers, and in that regards, a very much inelastic supply of automobiles. Number two determinant of elasticity is what's called spare capacity. And we're actually seeing quite a bit of this right now during the pandemic that's going on. There are certain businesses that ordinarily would be shutting down because they are not producing what's considered a necessary item for basic life support systems. And what they're doing is they're switching their production over to something that is considered essential. And therefore, they're able to keep their factory up and operating, keep their people employed. And so generally, when we talk about spare capacity, we talk about a corporation's ability to speed up or slow down the amount of production that they do. Let's say you're making Tickle Me Elmo dolls, and the demand for a Tickle Me Elmo doll 30 years ago was the must-have Christmas present for 6-year-olds. When the demand for Tickle Me Elmo goes through the roof, the factory that produces this doll, if they've got some machinery that may be producing other types of toys that they can swap over to produce the Tickle Me Elmo doll, they can ramp up their production very, very quickly, and consequently, they can get more product out on the market to meet that demand. So if there's a lot of spare capacity, if it's fairly easy to switch the machinery from producing one item to another, local distilleries, for example, um, some of them have switched from producing alcoholic beverage to using their distillation equipment to produce isopropyl alcohol for hand sanitizer. The ability to switch your production around so that you can increase the amount of a certain product that you're putting on the market is called spare capacity. And if you have a lot of spare capacity, your supply is said to be elastic. Now, there are a lot of companies out there that do not have a spare capacity. We see a lot of this in small companies. Um, Oddly, one of them is Boston Brewery. I believe they still do this, but for the longest time, Boston Brewery did not own their own brewery. They would actually they would go find other breweries like Budweiser or Michelob or Stroh's or places like that that had these big beer brewing setups, and these companies would have some downtime. They would be producing beverages, and when they had enough stockpile, they would just shut down their brewing facilities for a month or more, and in that way they would reduce their costs while the stockpile was being used up. Well, what Boston Brewery would do, the makers of Sam Adams, is they would go to these big breweries and they would go, "Hey, your brewery is shut down for the next 4 weeks. we'd like to rent your equipment. And they would contract with these major breweries to use a facility for a month or two while it would otherwise be idle. And they would produce what beer they could during that time. And then when their contract was up, they would, of course, clean up and clear out. What this meant was that if there was a sudden surge in demand for Sam Adams beer, Boston Brewery did not necessarily have the ability to react quickly. If they needed to increase production, they would actually have to go out and find another brewery that was idle and make use of the facilities, and it would take time. So when you have little to no spare capacity, your supply is said to be inelastic. You cannot adapt quickly to an increase in demand. If you do have a lot of spare capacity, your supply is said to be elastic. Number 3, determinants of elasticity, ease of switching. This goes back to the example I was talking about with the local distilleries, switching over from making ethyl alcohol for the purpose of alcoholic beverages to making isopropyl alcohol for the purpose of increasing the supply of hand sanitizer during the pandemic. The equipment is the same. The procedures are nearly identical. The only thing that is really different is the raw material, with ethyl alcohol using malted grains and such, and isopropyl alcohol using some other type of product to generate the alcohol from. So when a company can easily switch back and forth between the products they supply, it's said that their supply is elastic. If they have difficulty in switching, it is said to be inelastic. So, car company goes out of business. Somebody buys up the factory, and they start making spare parts for lawnmowers or something like that. It's very, very easy for certain machinery to switch back and forth between different products, especially things like injection mold machinery, where the press is more or less the same for anything. You can change out the product merely by changing out the shape of the mold that you're using. So if you have that ease of switching, you're said to be elastic in your supply. Ease of storage is number 4. This goes back to the propensity for companies to stockpile. And of course, we have certain items on the market that you can stockpile and certain items that you cannot. For example, it's very, very difficult to stockpile fruits and vegetables. Even if you were to freeze them, frozen foods can only stay frozen for a certain length of time before they start to suffer freezer burn. The texture of foods changes if they're frozen and thawed, especially if they're refrozen. Meat is absolutely horrid if you freeze it, thaw it, and then refreeze it. So you can't stockpile a lot of food stuff. You can't stockpile stuff that's biodegradable. There are other items, not necessarily organic. Certain types of plastics or rubber will have an expiration date, and it's where the material that the product is made out of will start to degrade over time if it's just left to the open air. So sometimes it's very, very difficult to stockpile. But when we talk about large inventories, obviously, if I have a lot of warehouse space and I'm producing something that is easily warehoused for extended periods of time, when there are changes in demand, it doesn't impact me much because even if I can't step up my production, even if I can't buy a new machine, even if I can't repurpose one of my factories from one product to another, if I have a large stockpile of that product in a warehouse somewhere, I can meet the increased demand without any delay. And so if I have that large inventory, if I have the ability to store large quantities of my product, I'm said to be very elastic. Now, inelastic supply, we see this a lot in retail. There are a lot of retail outlets that have gone to what they call just-in-time inventory. If you've ever been down to the outlet malls near Grove City, you know that if something is not out on the shelf and you say, well, do you have any more in the back? There are actually some shops there where they'll just laugh at you because they don't have a back. Or if they do, it's a toilet and sink for employee use and a couple of shelves in the corner. They don't maintain a lot of room for their inventory. And what these retail outlets are doing is they're ordering from their suppliers on an almost daily basis based on their actual sales over the last few days and their projected sales going into the next week. And so they will order from any given supplier, say once a week or twice a week, and they will order in very small amounts. If they get a little bit of overage, they might have a little bit of storage room, but not a lot. So a little bit of overage isn't bad. But because they're ordering in such small amounts, there's also a very strong possibility that on any given day, they might be out of the product that you're looking for. So smaller inventory, very inelastic supply, larger inventory, very elastic. Number 5 is the length of the production period. And we talked about this when we were discussing Karl Marx and the concept of a government planned economy. If you recall, one of the disputes between the theories of Karl Marx and the theories of the Austrian School of Economics was that it is next to impossible to execute a planned economy with any kind of efficiency because it relies on the central decision-making entity, in this case the government, to predict what the population is going to demand 2 to 5 years down the line, and then line up the natural resources, the raw materials, the production capability, and the trained labor force to be able to produce those items. And if they're wrong, then what you've done is you've set yourself up for failure because you can't know that you're wrong until you're into the 2 to 5 year window. And then it takes you a significant amount of time to switch over production to whatever is in demand. So this is especially true when we look at items that have a very long production period. Now, you want to order a car and you don't want to buy one off the lot. So there's some very specific options that you want on your automobile. You go to your dealer, you go, here's the car that I want, here's the options that I want, here's some options that if they're on the car, that's okay, but I don't want to pay for them. And here's some options I absolutely do not want. Odds are they're not going to find that car on their lot or on any lot nearby. So they will place the special order with the automobile manufacturer. And it's likely that you will see that car delivered within the next 2 to 3 weeks because it's actually very, very quick production time on an automobile. They can stick one special order right into the assembly line, knock that puppy out in the span of a couple of hours, however long it takes for the automobile to go through the entire production line, do the inspections, do the prep work, and ship it to the dealer, all within a span of just a couple of weeks. Agricultural products, a little bit different. If you're looking at steak, you got to birth a cow, You got to feed that cow for about 3 years until it's big enough that it pays to butcher it. And then you got to process that cow. So your production time on farm animals is anywhere from 1 to 3 years. Your production time on crops is generally the growing season, from planting in March, April, May to harvesting in September, October, November. You're looking at anywhere from 5 to 7 months of production time to react to a change in demand. So when you have a supply with a quicker production period, you have an elastic supply. When you have a supply that has a very slow, lengthy production period, that supply is said to be inelastic. Item number 6, time period of training. This is one that a lot of people don't think about because when we talk about resources, we talk about land, labor, and capital as the 3 resources that we have in order to be able to do production. But most people forget that labor is, in fact, a commodity, and that you have to um, have a trained labor force in many cases, just like you have to have particular raw materials, particular uh, preparation methods for production. Um, Everything that is true for land and capital is also true for labor. And so if I have one of 2 cases, if I have a job where I need unskilled labor with very little training, I'm actually hitting on 2 cylinders there. I can go hire anybody off of the street. I can bring them into my shop. I can give them a few hours of familiarization with my procedures, and I can put them to work right away. Um, let's take a look at highway workers, because you have both skilled and unskilled labor in your highway workers. Unskilled labor, the person standing there with the little stop sign on the front, yield sign on the back, and a walkie-talkie. Um, you basically just run down the uh, safety procedures for making sure that you don't put vehicles traveling 2 directions down the same lane, and you teach them how to use the radio, and your training period is actually very quick. By contrast, the guys that are dumping the macadam into the hole and running over it with the steamroller, um, they've got to have training in the use of the heavy equipment. They got to have training on the um, factors involved in keeping the paving material in its correct state, not too liquid, not too solid. Keeping, like macadam has to be at a certain temperature. They've got a little bit of engineering education that goes into it, so that they make sure that they have everything both mixed correctly and that they're installing it correctly, and so on and so forth. So their training period is probably a matter of several weeks, maybe even a couple months. And then you look at the engineer. The guy who's designing the road. This is a guy that had to go to college for 4 years. And even when he gets through college, where he's got a lot of theoretical engineering training, now you hire him into your company and you've got to teach him all of your company's procedures, policies, any particular idiosyncrasies that you have in the application of engineering principles, and so on and so forth. So his training period could be, with just a bachelor's degree, it could be the 4 years of college plus a year with the company before he's able to go out and function on his or her own. So for the labor force, the less training time that you have for your labor force, the more elastic your supply is, either because it's easy to bring new labor into the labor force, or because it's easy to transition my labor force from one task to another. Because if I take a person who's used to driving a forklift and I have to teach them how to drive a dump truck, um, if depending on the lag time in being able to retrain my existing workforce, my supply time may be more or less elastic. Factor mobility. This one's kind of tricky to understand. But when you talk about factor mobility, you're talking about the movement of resources into or out of an industry. So we talk about raw materials. Let's talk about the steel market. Steel requires certain minerals, certain elements to be present in the blast furnace in order to produce um, particular types of steel. Depending on what type of steel you're making, means that you might have different materials that are due in. So, how did Pittsburgh get to be a big steel town? Well, Pittsburgh got to be a big steel town because most of Western Pennsylvania sits on a pile of iron ore. So it was very easy, and you got West Virginia sitting on a pile of coal. So it's very easy for um, the coal, the coke, the steel, um, and the iron ore, those materials to get into the steel industry in the Pittsburgh area. Now, by the same token, if I were to try to set up a steel plant somewhere in Vermont, it would be much more difficult for me to get the resources into my industry in Vermont, and therefore much more difficult for me to keep my supply elastic. Um, and you can look at a variety of different industries, and you can see how factor mobility works. For instance, if you look at your oil refineries, most of them in the United States are on the coastline in the southeast or on the Gulf Coast in the Gulf of Mexico, because that's where most of the oil is coming from. If you look at um, most of your automobile production facilities in the United States, most of them were built in the vicinity of um, other industries that were creating the steel or the plastic and rubber parts that went into the production of automobiles. So industries tend to set up where it's very easy for them to get their resources into where they are. And by contrast, let's look at processed chicken. Tyson Chickens, they own Holly Farms, Tyson, and I forget the other one, own just literally thousands upon thousands of poultry farms in the southeast United States and around the Midwest. But they don't process their chickens in the United States. So when they do a slaughter, they actually ship their chickens over to China for processing. China processes the meat and then ships it back to the United States. Very, very low factor mobility. If we wind up having a spike in demand for chicken, the very fact that we're shipping those chickens overseas to be processed and then shipping them back means it's very, very difficult for those resources getting back and forth between the farm industry, the processing industry, and then back to the retail market. So a very, very inelastic process. Last but not least, we have what we call reaction of costs. And this is the speed with which supply reacts to price changes. And I'm going to talk about the oil industry here. If you look at the oil industry, even with the supply of oil that we have here in the United States, we still import oil from the Persian Gulf region, as well as from Southeast Asia. So how does that oil get here from, say, the Persian Gulf? Well, they pull it into a port somewhere in the Persian Gulf, they pump it full of oil, and then the ship sets sail. And it has to sail either up through the Suez Canal and out through the Mediterranean, or it goes around the southern tip of Africa, and then it crosses the Atlantic Ocean to get to the refineries here in the United States. How long does that trip take? On average, somewhere between 30 and 90 days, depending on which way they're traveling and things like weather and ship capacity and that sort of thing. So what happens when the oil Organization of Petroleum and Exporting Countries get together and Saudi Arabia and decide the price is going to go up? So Saudi Arabia changes the price of a barrel of oil from, say, $100 to $120 a barrel. Are we going to see the price of gas at the pump go up right away? Well, probably, because that's kind of how oil companies function. Let's look at it the other way around. Let's say they lower the price from $120 a barrel down to $100 a barrel. Are we going to see the price at the pump drop when that happens? And the answer is no, because the price of oil that produced the gasoline we're seeing at the pump, that was oil purchased a month, 1 to 3 months ago. We contracted for that oil. It sailed over from Saudi Arabia. It goes to the refineries, and it gets turned into gasoline. And the lag time is from the time that the oil hits the refinery is probably several weeks before it's gasoline in the pump. So you're looking at that 1 to 3 months of shipping plus the 1 to 3 weeks of refining and delivery. So if the price changes in Saudi Arabia today, the price at the pump is not going to change for anywhere from 2 to 4 months. And because of that, the reaction of costs is very, very slow when the price of oil drops. Now, it's very, very fast when the price of oil increases, because I guarantee you, if they up the price of oil in Saudi Arabia by $20 today, the price at the pump is going up by 20 cents tomorrow, just based on the news that future oil is going to be more expensive. That's called profit taking, and it's actually very, very common. But on a price drop, you're not going to see the price drop until that cheaper oil is actually in the refinery. And so when we look at oil price changes, we're looking at a very inelastic supply. Now, conversely, pencils. Pencils is probably a bad example. Let's look at something we can make really, really quickly. Oh, heck. Let's look at meat. So let's say we got beef. Now, ordinarily, beef cattle are selected for processing based on their age and size, and it's usual that there are certain periods of the year where cattle are sent to the meat processing plants, and that's all well and good. But if you have, let's go back to maintaining that large inventory. If you've got farmers that have a large inventory of beef cattle, if the price of beef rises, it's an easy decision to make. Instead of sending up the 50 cattle you were planning on, send up 70 cattle to the processing plant. If it's easy to move around those raw materials, or it's easy to react with production speed and with other capabilities, to react quickly to the changes in cost, then the price is said to be very, very elastic. And so those are a couple of examples. Now, why does it matter? Well, maximum profit. For the manufacturer, the producer of the goods, the ability to adjust to changes in demand maximizes the odds that the quantity supplied at any price is going to match the quantity demanded at any price. And when we look at market equilibrium, we're going to look at where the demand curve and the supply curve cross. And when that happens, the point where they touch is called the equilibrium point. And that is the point of maximum profit, when quantity supplied and quantity demand actually equal each other. If you have excess supply, you have waste. If you have excess demand, you have lost potential because obviously people are willing to buy more, they just can't find it. And so the producers, the suppliers, the manufacturers, these guys are all going to look at the factors that feed into elasticity of supply, and they're going to attempt to make themselves as elastic as possible so that they can react to those changes in demand appropriately and efficiently, and thus maximize their profit. So I'm going to stop the screen share there. And I will tell you that there will be a worksheet that's dealing with elasticity of supply. It will not be like the demand worksheet at all. It's going to be dealing more with the equilibrium factors. And so we'll probably be talking about that next week. But if you have not watched part 1 of this video, where I talk about supply curves and the factors that cause supply curves to move left and right, please go back and review that. If you have any questions at all about anything in this video dealing with the elasticity of supply, you can get a hold of me through my school email and or through Google Classroom, and I will be more than happy to answer those questions. When we look at market equilibrium, we'll be talking about the supply curves and the demand curves crossing, as I said before, and look at the different factors that make what we've learned up to this point important to both the consumers and the producers. And with that, I will see you next time around.